Thank you. All right, thank you, everyone. So I'm here, as she mentioned, to talk about the content security policy and some of the challenges I've seen, both as a vendor who consumes the reports and does some analysis, as well as a security leader for several acquisitions of a large software company and trying to get them to include the CSP header as well. So I'm not going to go over the CSP RFC and all the different trivia things. There are a few good talks out there. What I really want to do is talk about the process and some of the tools that we've been using to help get that process started and make sure that you don't fall into some of the pitfalls that we have before too. So I'm going to go over a brief refresher of CSP, how to make a case for CSP inside your organization, how to approach the different teams about content security policy, some things we've done to make the reports more valuable for analysis and some big data stuff, and how to track your progress when you're announcing inline scripts, because that's a big one that comes back is, hey, just add nonces everywhere. Well, how do I know what inline scripts are there in the legacy applications? So we're going to be open sourcing a piece of software that will help you do that. And then some neat CSP tricks that I've done that you may or may not find interesting, but could help with the analysis as well. And then some thoughts on the Google CSP research paper, which came out shortly after I submitted this talk. So it's pretty good timing, but I agree with some of the stuff and disagree with a little bit of the conclusions. But if we have some time, we'll go over that as well. So a little bit about me. I work for tsol.io. We're doing RASP-type work along with WAF-type signals and trying to combine the best of both of those worlds to develop a picture of what an attack is, a better confidence in that an attack is happening. And so content security policy is part of that. It's telling us what resources are being loaded from where and if new inline scripts are showing up in the page. Prior to that, I've been working as a developer. I've been a consultant and a pen tester, and I've worked in the product security team at Salesforce, and then moved to direct their acquisitions of different companies. So I got to work with a bunch of different startups sized 10 people to 2,000 people, and bring their security up to the Salesforce standard. So that's been really interesting as well. So introduction. So if who here is familiar with content security policy? If you're spending your lunch hour here with me, then yeah, probably, I'd hope so. It's a response header. It instructs the browser where it can load resources from, and it restricts some things like the eval function. It's really, I think of it as a bouncer. It's going to tell the browser what things can be loaded in there and what the page can load. It comes in sets of directives and then sources, keywords, hashes, and nonces. And we'll cover some examples of that. However, we will not go into all the directives, as I said. This is not a deep dive into all of these, but as you can see, there are lots of things you can do to tune the content security policy. So this is a very simple example. Here we have a content security policy header returned, and it says, if something's loaded from the same domain as the application, resources loaded from that URL, or it's loaded from a subdomain of example.com, then it can load it. Anything else that's omitted, it's going to deny. So unsafe inline, unsafe eval, or another domain, it won't be allowed. In CSP1, if we wanted to add an inline script, we'd have to add unsafe inline, which sounds really bad because it is. And so this talk is going to cover some ways we can get around that and move away from it. If we use some other directive, like font source, what will happen is, it'll only apply to the font. So in our previous example, the scripts can be loaded from anywhere now. So if you omit a directive, that means it's globally allowed. And then there's the report-only mode, which is extremely useful for tuning these CSP reports. So in this example, we send the reports to example.com CSP report, so it's going to post a JSON report there. And we'll dig into some of the report differences from the different browsers as well. And one of the things that's useful in making backwards compatible CSP policies is the fact that it just ignores unknown keywords. So if you have some keyword that doesn't make any sense to the current CSP version, it's just going to ignore that. And we'll see some strategies for how to use that to create a policy that's meaningful to CSP1, CSP2, and CSP3, all in different ways. And so what are some of the technical or challenges that we've run into? So there are a couple types. There's the technical, so the browsers report violations differently. So we'll go through Chrome, Firefox, and Safari and some of the differences there. There's going to have, if you have legacy applications, there's a ton of inline scripts, so you have to know what to do with those and know where they are. And then you could have hundreds of sources across sites. So we've run into teams that said, no, it's okay, we use frameworks to make sure that we're encoding the output okay. We add CSP, and they're also including JavaScript from 200 different domains. That's a security problem in and of itself. And then there's the cultural stuff, which is when you go to tech ops and say, hey, we need to add this header, or the development teams, we need to add this header. Like, how do we convince them that it's not just a nice to have? What other drivers can we have for this? And it's difficult to coordinate across teams as well. So if we have somebody who we need to work with to consume the reports, somebody who needs to tune the reports, and somebody who needs to then go update the reports, depending on the size of your organization, that may prove difficult as well. So the solutions that we've come up with are to start with a permissive policy, and I'll explain why in a little bit, and to have a plan to move towards a more restrictive one. So you don't have to have a perfect policy or a policy that blocks everything right out of the gate. And this is one of those cultural things as well. So I go to a lot of meetups around the Bay Area, and this is from a Node.js one I went to. And he did a brief, he was going to talk on security, and he said, hey, just include these couple lines, and you don't have to worry about cross-site scripting ever again. And so this is part of the culture, is not only knowing that CSP is difficult, but to communicate that to developers on how it works. And what this, when you make your plan up, you have to communicate that plan to them as well. All right. So first, make a case for CSP. So the first one is probably change management. You want to know what sources you're trusting. So it's a good idea to use CSP not only in production, but also in development, so you can see and get those reports if a developer is all of a sudden including something from some host that shouldn't be trusted. Because you don't want to wait a long time and then be stuck with something that you weren't involved early on in the process, and now you're unhappy with what's there. You also want to know what sources are added so you can make it a part of the change management process. You can make a process around approving those things and have a paper trail. It also makes your code base more reliable. So this is a good sell for tech ops or something like that. At Salesforce, you had the idea of trust, which is security and reliability together. Because not only does the information have to be secure, it has to be available too. And so if you're depending on scripts from 100 different domains, all those 100 different domains have to be up and working as well. And if there's a DNS problem with one of them, all of a sudden your site might have problems as well. And so this can be a great driver for pushing CSP and reducing the amount of people that you're trusting to run code in the context of your customers. It also makes the behavior predictable, which should help with QA and testing as well. And then there's compliance. And I think one of the big drivers for security stuff is not only to help achieve compliance, but to reduce the time we have to spend with compliance teams. And so if we have that list, not only that list of domains that we trust and how we're allowing JavaScript to be executed, but we can provide proof that we're enforcing that, it can make, for less meetings, which should make everybody happy. And the last one is removing inline scripts. So I think everyone in the security community would agree that removing inline scripts would be ideal for your site. You want to, if you have to add unsafe inline or manage hashes and nonces, it's a lot of trouble, and it's easier just to remove them and use included libraries instead. So how do we remove those inline scripts? So I'm going to go over some of the stuff in CSP 2 and 3 real quick. For CSP 2, they introduced hashes, which you can include a hash of the script body. in the header. If that matches the script that's executed, then you're allowed to run that. The browser allows it to run that script. This doesn't scale incredibly well because you'll have to hash every script. And if you have a bunch of inline scripts, your CSP header is going to grow quite large. The other one, which is more promising and is moving a lot faster, is the nonces. So then this one, you include a random nonce every page load. However, and then the scripts will include that nonce in there as well. And the way this is done is the template, your template has to include a variable that can be replaced with that same nonce header that's included in the CSP header. And then if a new script shows up on that page, either inserted by the DOM or through reflected cross-site scripting, it won't be run because it does not have that nonce. In CSP3, they added strict dynamic. And so with strict dynamic, what happens is everything's going to have a nonce. So we'll look at a backwards compatible strict dynamic policy, but in this case, you may have 50 or so domains, and you don't want to whitelist them all in the CSP header. So you can just use a nonce in every script tag, and that'll allow things. However, that rules out things like the subdomains and keywords, except so only hashes and nonces are available then. So when to use, if we have too many domains, URL scripts, the CSP header is going to grow too big, and we're working towards a policy, but this is sort of an intermediate step then. And this is a backwards compatible CSP policy. So here you can see what it would look like to a CSP1 browser, a CSP2 browser, and a CSP3 browser. In CSP1, it doesn't know the nonce keyword. It doesn't know the strict dynamic, so it ignores those things. The only thing it's paying attention to is allow unsafe inline and allow those subdomains. And CSP2, it'll pay attention to the nonce, which rules out the unsafe inline and allows those things plus the subdomains if they're included in the script. And CSP3 browser, it'll only pay attention to the nonces, the strict dynamic keyword, and the hashes if you have any of those in your script as well. And then we have unsafe hash attributes, which is a work in progress in CSP3. And this is for event-based things. So if you have an on-mouse over or on-load or something like that, and you want the hashes to apply to that as well, since we can't nonce those, you can use that property inside your CSP header to achieve that. And so now I want to talk about approaching teams. So this is probably one of the hardest things about CSP is to actually get them to buy in. And the goals of your plan, you want to not affect performance. So while CSP reports are asynchronous, and they're going to be sent from the browsers, if you send about more than 10, you're going to see a sort of UI slowdown because the browser is going to be working on compiling those reports and sending them to it. So the UI team will start to see some performance degradation on the browser side. So we want to limit how many reports are sent because that's the fastest way to get your stuff out of production is to cause any sort of issue there. We also want to make sure we're clear it's not going to affect any JavaScript functionality. We're going to be in report-only mode at first. That it doesn't actually block anything. And we want to make someone else's job easier. So I was talking about compliance. I was talking about stability. So use those things to try to sell the CSP inside your organization. And then we want to have a path to blocking mode. So have a goal in mind at the end of this, which is we want to be able to lock this down. We want to be able to say we only trust these sources. If you want to add more sources, here's the process, and it'll be added to the CSP header. So when we approach front-end engineering, we want to say, report-only does break things. You may see some console error log messages. That's OK. It's going to show up as red bars in Chrome console, but don't worry about it. It's not actually blocking or causing an error. And then we want to make sure it's a phased-in process so that we're not causing any performance hits. And the way we do this is we start with a really permissive policy. So here's something where we're permitting just about everything. So we're permitting anything over HTTPS. We have unsafe eval, unsafe inline, and self, and some known CDNs are thrown in there, even though they'll be redundant at first. So the first thing we're going to do is we're going to remove HTTPS and WSS, so the WebSockets over SSL and any SSL stuff. So what this will do is it'll send violations for any unknown CDNs that we have while allowing all the other things. And so we can collect those reports. We try to modify the CSP header, and we may need to add in some other domain or some other JavaScript that's whitelisted. And then we aim for about a week of, say, no CSP reports coming in. And then we'll move on to self, and we'll move on to unsafe eval and try to, if we need it, we add it back in. If we don't, we remove it from the policy. Yeah?
Why would you want to remove self?
It's just reducing the attack surface. It's less stuff you have to trust.
But not trusting yourself, but that's why you're serving everything from anyways.
There may be a situation where, I don't know, there's unrestricted file upload or something on your site, and somebody could upload a .js file somewhere, and that would increase the severity of that finding then. So then you go through unsafe inline, and at that point you can decide whether to add unsafe inline or if you want to invest some time into doing the nonceing or the hashing, depending on how many inline scripts you have. And then you can complete it and move on to the next directive. And so you keep doing that, and you go through that cycle, and you do it very, you just have this test. This is a subset of the directives, just to give you an example of like what your plan might look like for going through all this and developing your content security policy. So the other thing we can do is we can make CSP reports more valuable. So I'm sure most of you are familiar with the CSP report. It gives you some limited information. But as we'll see, there's no way of knowing whether one page generated 30 CSP reports or it's one CSP report per page. And if we're in the application server or even in Nginx, we can make some changes that may be able to help that. You also have to recognize the differences between the different browsers. So some properties are included with some browsers and some aren't. So here's an example of different properties included from the latest Chrome, Firefox, and Safari. And so you might have to combine the reports from the different browsers to create a complete picture here. And every browser is special. So for unsafe inline and eval, one of the problems we ran into early on was the browsers definitely don't report this consistently. So Chrome will report it pretty clearly at the blocked URIs inline or eval. Firefox will report it as self no matter what. And you have to sort of look at the script sample, as we'll see in the next slide, to determine if it was actually an eval violation or an inline script violation. And in Safari, it'll report as self for unsafe inline, and don't worry about eval because it doesn't actually report that. So you can safely assume that it's unsafe inline at that point. Hopefully, they're all moving towards the Chrome standard soon. And so this is what it might look like when you get a report back from Firefox. And you want to determine if it's a unsafe inline or eval. So if it's an eval, it'll always be that string call to eval or related function blocked by CSP. And then we do some A/B testing as well. So one thing that's not really well documented is what happens when you mix headers. So if you have both a content security policy and a content security policy report only header, what happens? So if you used two completely different directives, for the most part, what we found was the headers are completely independent. You'll get the different reports depending on the header and the violations. So you may get duplicate reports if, in some cases. However, if you mix and use script source or the same directive in both the content security policy and content security policy report only, you're going to get a little bit different behavior from Safari. It's only going to respect one combination of directive and source, and it'll be the most restrictive one. So you may miss out on some reports if you don't look out for that. And the reason we do that is we may want to keep a more restrictive content security policy. And then use a report only to see if we still need some of the things in there. So as we, like, in about a year, you want to see if you're still using a domain, you can modify the policies so that it might report only, it might not block it, but it'll send a report only report if it's in use. The other thing we can do is sort of modify the report URIs. So one of the tricks that we use is to add some properties to the report URI by adding arguments on the URL. So we add a transaction ID, so that's per request, per page load. We have a HMAC of the session ID, a route ID, which is sort of a hash of the controller and the method, and sometimes the user ID, and depending on the privacy settings, an HMAC of that. So we can match all that up in the reports. So what can we do with that? It might look something like this with RID, SID. When we get that report in, we can parse that and match up all the CSP reports to a single session. We can match it up to, we can tell if the user was authenticated, if the user ID is present. And we can match them all up to a certain transaction as well. So if one page is creating most of the CSP reports, we know that versus several.
So are you using the actual session ID of the user who's logged in right now?
We're using HMAC of the session ID, sometimes truncated as well. So maybe like HMAC and then cut it in half or something like that. So we definitely don't want the actual session ID in the URL, but we want something that we can match up. A couple warnings: don't rely on reports. They can be easily faked. We haven't seen anybody do this yet, but it's possible that they could be, create a bunch of fake CSP reports if they know where your CSP reporter is, because they're completely unauthenticated. They're not going to send any authentication cookies or anything like that to the CSP reporter. So somebody might be able to generate, fake hide-in-the-noise type CSP reports. So you definitely want to keep track of IP addresses as well when you collect those CSP reports. One of the other things we're doing is, back on this URL, is we're adding a sort of checksum variable at the very end. So we'd add a C equals and then this, and that is a shared secret that hashes that URL, so we can tell if they've modified that. And that just increases the difficulty of them faking the CSP reports as well.
It sounds like you encountered fake reports, right?
We're anticipating encountering them. We haven't encountered them yet. But I guess my mind thinks that way. It's just like, that's what I do. So the other thing is some directives won't work in report-only mode. So if you have things like frame ancestors or sandbacks that you want to add, you have to be careful with these because even if you add these in report-only, the browser is not going to send reports for these directives. So you have to know ahead of time what those are and be sure of those things. So frame ancestors is what frames are allowed to frame your site. And we'll go over a trick we use to get around that one, though. All right, so we have one of the most popular issues we ran into was dealing with inline scripts. So we'd say, hey, we want to add CSP, and they're like, yeah, that's great, but it's going to be pretty much useless because we have inline scripts everywhere. And so we developed a JavaScript profiling library, and we're releasing a version of it open source, which keeps track of if the script tags have nonces, or if they, it'll also hash them for you. So if you want to collect the hashes of the scripts that are in all the pages, you can collect that information as well. And so what the agent does is it's a JavaScript agent, sits at the top of the page in the head, and it'll instrument the DOM. So as things are added to the DOM, it'll inspect them. It'll inspect the body of the inline JavaScripts, or it'll inspect the script tags and what resources they're loading. And so it collects some meta information as a sort of wrapper around that, and that is it'll collect a request ID, which is a random ID per page load, session ID, which it keeps in local storage, and a document URI, and the refer if it's available. And then there are various events. So there might be a script source event, which tells you that a page loaded a JavaScript from source other than self. And so you can keep track of that domain and where it's located in that page. It'll also pull some script context around of the surrounding tags. So in this case, we can see, it's surrounded by the head and another script tag as well. However, it won't pull, values unless it's like a class or ID, which will help you identify where in the page this is. And then if there's an inline script, it'll create a slightly different event, and that'll give you a SHA-256 hash of the script, as well as the location where the script has and if it has a nonce or not. And so this way you can sort of start tracking metrics on how many inline scripts you have on your page and what percentage of them have nonces. So it's part of that phasing in the CSP policy. Maybe you can't get nonces in all the scripts in the next week, but over the next 2 months, you sort of build a metric around how many did I get this week, what's my percentage at the next week, and so on. And so you can show progress, and that makes it it's a lot more encouraging that way. And so this version of this, we'll be opening this up today, is the CSP Inline agent. So please show some interest in it so we can continue developing the open source version, or if there's other features you want. We're already starting to add in some more things, like letting you know if document.cookie was accessed, or other things that might be helpful to secure scripts, and let you know if there are malicious ones. This will work on event-based, so if there's an on mouse over, that'll show up as a script source as well, and you'll get a DOM location of that. And now some CSP tricks. So one of the things we had was we have this JavaScript profiler, and we have CSP that are coming in. We sort of want to match those two things up. And so what we thought about using was an intentional CSP violation. And hopefully they don't change anything to prevent this. But it's sort of a neat trick where we use, a blocked URI will only specify the domain in some browsers for privacy reasons. So hiding identifier in the path wouldn't work. And making a random subdomain, that provides us an identifier in the blocked URI, but then we're going to cause a bunch of DNS problems, caching, and we're probably going to get blacklisted as well somewhere because we'll look like a piece of malware. So a little bit of IPv6 trivia. There's a discard address space. It's 262 to the 64th spaces. It is not routable. So we wonder what happens if you make a CSP violation to this or a connect source to this. And so what we do is we build that. We build our request ID so it fits in that space. We make an intentional violation to that space. And if you see, the port number can also be specified. So that's a couple extra bytes if you needed more address space to specify something. What's going to happen is now the JavaScript has this request ID that can submit additional events to our listener with that request ID. And we have a CSP report, which has both the transaction ID and session ID, as well as that blocked URI with our request ID. So we just parse that out of there, match them up, and now we can combine CSP reports and our JavaScript information as well. And you can either use a live update in the CSP event, or you could have a link table in there as well that would allow you to more lazily do that in a historical manner. One of the other things is we wanted to have a report only for frame ancestors. The browsers and the spec don't currently support this. So do we use frame busting code? Like we could look at the parent and try to tell if it's framed and try to guess some stuff, but that doesn't work if like multi-framed pages. And maybe frame ancestors applies to grandparents and great-grandparent frames, which it does. So if we add an invisible iframe inside our site, which has a CSP header with frame ancestors and a report only, that invisible iframe might get blocked, but the report will still be sent. So our page will still function normally, and we'll be able to tell which sites are framing us. I guess you could set it to self or something like that. Yeah. But yeah, this one would be violated all the time. All right. Any questions on that one? Okay. And the Google CSP paper. So this came out, and quick summary is, there's a lot of ineffective CSP policies as far as cross-site scripting is concerned. No disagreement there. Lots of unsafe inlines because that's the cheat people use because they don't want to track down all their inline scripts. And that makes it extremely easy to, when there's reflected cross-site scripting, to exploit that. They also noticed a lack of object source. So it's a lack of knowing the bypasses that are available too. So if there's no object source defined, then any object source is allowed, as we said earlier. And so they have, they show a couple of bypasses here where you can do things with like the data, if data is allowed or if object source is allowed, things you can do to get around the script source. So their recommendation is nonces and using the script source strict dynamic to create some backwards compatible policies, which I agree with, and hopefully our JavaScript library will help some people track down all those script locations and get the nonces in there as well. It's the paper is much bigger than that. This is a very quick summary. It's probably a presentation in of itself. But that's sort of the basics, and they released a couple of cool tools. One is the CSP evaluator, which will show you like any weaknesses inside your CSP policy. So you just paste it in there, and it'll let you know. And the other one's a browser for plugin testing. So you put this into Chrome, and you browse your site, and it'll tell you, what sort of violations are occurring on the site. My thoughts are, don't be discouraged if there are holes in your CSP policy. Keep working at it. It doesn't have to be perfect at first. It doesn't have to even stop all cross-site scripting. There could be workarounds, but make it more difficult for the attacker, and use it for what it's also valuable for, the change management and keeping stability on your site. But make sure you keep that end goal, that you will eventually get to the point where your CSP policy is preventing cross-site scripting. So my summary is, don't tackle CSP all at once, especially legacy apps. Do it in, stages. You don't want to create any performance problems. Plus, it's just a ton of work to look through all those reports. It's much easier if you just try to tackle directive by directive. And track your progress. So use something to track how you're doing, even if you're not able to turn on nonces right away. Make sure you know if you're like 20% of the way there or 80% of the way there. And used CSP to drive other security and stability objectives. So reliability, compliance, things like that. Make it important inside your organization other than to just the security team. And remember that CSP report URIs can be annotated, and you can do some interesting things with CSP that can make it extremely powerful, especially when you tie it in with the JavaScript events. And if you run across size limitations on your CSP or something like that, you may be able to use that information to create custom CSP, like for certain routes or application areas. Admin / may need a different CSP policy. So keep track of those things and group those CSP policies together that way. We keep track of, like I said, the IP addresses. So that's where that fake CSP report comes in. They sort of fall into the same category if we just see it from a few IP addresses. And we have sort of the position of some of those scripts. So if we match those up with the JavaScript event and we know like the DOM was modified and added a script in the head tag, that's a lot different than if it shows up in the middle of like an on mouse over and somewhere in the middle of the DOM. And there's a CSP violation there too. So it's sort of grouping those things and knowing if it's just like one IP address causing it or if it's multiple or a subset. But yeah, it's a common problem is how to deal with that. So I think the best way is to group by those and then just try to filter out that noise there. So that's one of the things we're working on as a service as well, is to do that and sort of determine if it's the subset is a cross-site scripting attack, or if it's just like plugins, and then we keep track of the domains and do reputation scoring on those as well. So CSP3 is still, I think, they're still discussing the directives, and they definitely have not finalized it. So some of the things may be supported, but having backwards compatible policies is extremely important. Yeah, depending on the language, there are a security header. It's usually a type of security header library. So I know Twitter has produced one for Ruby, and there's a similar one for Python as well that cover Django and Rails. But most of them it's pretty straightforward if you're not doing some of the more dynamic stuff like we are. So you can even do it at the Nginx or Apache level as well. And there's Helmet, as we showed in that other one. Although it's a little bit more complicated than just calling add CSP. So. All right. Any others? OK. Thank you, guys.